Hello and welcome to today's live stream. I'll be continuing to do some work on the governance simulator. Made a bit of progress in the previous streams, mainly around persistence. So today my plan is to push that a bit more forward. The modeling is pretty much done, unless other issues emerge. But I think there is a significant enough data layer that would help to build out the initial versions of the simulation, and the linkage between SQLite and Swift using the C interface provided by the SQLite library is pretty much done. The thing I was working on in the last stream was establishing a schema, which is just a set of queries that would set up the data, the persistence layer for the simulation on the SQLite side of things. The goal is to have this schema written and maintained from Swift, executed through the C SQLite interface, and most of those queries will be running from Swift to SQLite. So I won't be writing any persistence logic with plain C. Instead, I'll be interfacing with the C API, SQLite C API from Swift. That means most of those queries will be written and maintained from the Swift side of things, which comes with its own advantages in terms of safety, in terms of maintainability. C code is a little more complex to maintain than Swift, because Swift provides some additional APIs, some additional syntax and tools that make maintenance a bit less of a hassle. So that's why I'll be doing most of the work from Swift. As the project progresses, if there's any library that I need to interface with, especially if it's a C library, I'll basically follow the same format. We find a way of establishing bindings to that library from Swift, and then having the actual code written in Swift and the calls to the library, have those run through the C Swift interoperability, which gives us the pointers that we've been using, like opaque pointer, the mutable pointers, and so on. So the last stream, I had left it to the point where I had this schema, which I haven't tested, so I'm not sure it works. Maybe there's some SQL errors here, like I'm seeing one. Yeah, I think I'm supposed to mention the column name here before listing the triggers, and also this I think needs to be in, like, let me just fix that. So this needs to be a relationship in this set. So for instance, this limits the values for relationship to trigger and apex as the only accepted value for that column. We could provide a not null here, but it would probably not be necessary. But if you wanted to, you could still have a constraint there. SQLite allows you to list multiple column constraints, as many as you need for that specific column. So the schema is mapping sort of directly with the, not completely directly, there's a bit of changes, but it's meant to map between the Swift models like metric here and how we would like to persist that model to the actual SQLite database. So there's a symmetrics table here that maps to that model, and you'll see it has the same properties: the name of the metric, the score value, the display number and description, and also the level. Levels are enumerations from the Swift side of the code, which means we can only have primary and secondary, that is 0 and 1. And on the schema, we can also specify that in the column constraints. So you can say check level in, this is level in 1 or 0. So that, I think that will help to at least limit how far, what kind of values can be accepted by that column. But the point is, this matches directly with the metric model, and this would be the equivalent of the enumeration that we are using. We could go ahead and use a string-based representation for this, but using integers has its upsides. But if you wanted to visualize this from the database itself and be able to derive meaning quickly, perhaps it would be easier if this was a string. So let me just change it to a string. And this becomes primary, and this is secondary. And on the schema, you can just change this to primary and secondary. So those are the only accepted values. So I've avoided using referential constraints, basically foreign keys. Instead, I have my own linkage tables. So there are cases where you have a one-to-many or a many-to-one mapping, many-to-many mapping between one model and another. And in those cases, like SimPolicy has affected metric, which points to a metric and the affected value. This is a bit different. Let me try and see something a bit more directly. Yeah, so like SimEvent has affected metrics, which is just a list of UUIDs. And the UIDs represent the IDs of the metrics that this event will affect. Trigger metrics, these are the metrics that are able to trigger this event, and that's represented by this array of UIDs. So the array of UIDs is just a list of metric IDs. So in some cases, you would for most people, they define a referential constraint here between the event and the metric. But I've taken a different approach. Instead of that, if you go to SimEvent, so SimEvent has the usual properties: the ID, the name, event source, crisis score, and timestamp. And I'm using text here because SQLite doesn't support a date type, as far as I know. But there could be functions for deriving the current date, which you can default to. Just check the docs for that. Yeah, date and time functions. Yeah, so calling date will give us the current date. Calling date time will give us the current date time. We find the date and time formatted as that. So since so I guess this depends on whether default accepts an expression. So there's a way to check for that, and that is under SQL grammar. See if there's a definition here for default. Not that default. table and table constraints. So you can have primary key, unique, check. It seems like default is not classified as column constraint, so I was assuming it should be. Because what you do with default is you can specify that if a value is not provided, this will default to some value. I'm not supposed to use double quotes there. So this will default to some value. The question is, does the syntax allow this value to be an expression instead of just a single value? Because if it did allow it to be an expression, then we could call date time here, and that would default it to the current date time. I'll leave it as such. If it doesn't work, I'll see it in the error messages. Hopefully I'll not have forgotten about it, so that if the error pops up without being descriptive, I hopefully won't get completely lost. But so if it worked like a check constraint, it should allow us to use datetime here. What I'm referring to is, for instance, this score value is supposed to be between 0 and 1. We can do a check constraint and pass in an expression. Score is greater than. In fact, I think we can do between 0 and 1. I think that should be allowed. So this is an expression. If we wanted the score to be at least less than 1, we could do score is less than 1, and that will serve as a constraint. I'm not sure about default though, so I'll just leave it there. If I see any problems, come back to it. Anyway, back to the thing I was describing. So the events have that list of UIDs of metrics that it's supposed to do associations with, and the way I'm making those associations is having this other table, metric event effects, and what it has its own primary key. It has the metric ID and the event ID. So the event ID will be the sim event ID, the primary key for that, and the metric ID will be the ID of the metric, sim metrics here. So it will be the ID of this, and we'll just have a list of them, and then the definition of the relationship between that metric and that event. So that's how I'll be able to kind of define that association. And I'm doing this for the other tables. Instead of defining a foreign key, I'm having a separate table. So the reasoning behind that is I don't want the schema to be too strict. And it's a selfish reason, because I want the migration scripts to be easier to write. If you have foreign key constraints, the schema is usually a bit more restricted, in that if you do a migration, SQLite, and I think most relational database systems will check for any values between the two tables that break that referential constraint. So if you refactor your data layer and that refactoring goes against the referential constraint that you had initially, then you're sort of tied by the database. Unless you are ready to give up the existing data or to get rid of that referential constraint, your migration script becomes a little more complex. And and also I want the application layer side of things to do more of the data manipulation, so I'm not relying on the database too much to maintain the consistency and integrity of the data. So I'm just passing these less strict constraints, like checking that fields are not null and checking that enumerated values actually match the enumeration criteria, like the trigger and effect values. But referential constraints are a little bit more strict, and I don't want the database to be too restrictive. I want the application layer to be a bit more free to kind of mess around with the data, but not to the extent that the the actual persistent data doesn't make sense. So that's why I have these other external tables that would allow me to kind of define relationships without the foreign key constraint. Most people would probably prefer the foreign key constraint, but that's just my style of doing things. And yeah, so that's that. The other thing I'm doing in this schema definition is I'm using UUIDs for the primary key. So this will be, the ID is 16-bit UUID 7. So since SQLite uses the same size for representing the UUID as Swift, I found it sensible to just have a blob representation for the UUID, basically a 16-bit value. So I can store that 16-bit value on that column, and when I'm extracting it from the Swift side, I'll just request for an encoded 16-bit string. It might not be represented as a string per se because it's a blob, but once it comes on the Swift side, I know it's 16-bit. So when I'm extracting it to become a string represented on the Swift side, it will be I'll be able to tell Swift that it's a 16-bit string, and since Swift can fit the 16-bit value into the UUID, I'll be able to convert it into a Swift UUID, because I'm also not using string representations for UUID on the Swift side. I'm using the binary representation. So notice my IDs are actually using this UUID, which is the binary representation. You can convert them back to strings, or convert a string to the binary representation of the UUID. But by default, I'm using the actual UUID value. Yeah, so you notice here you can extract it from a UUID int, and this UUID int is, yeah, it's a 16-bit block. So yes, that will help with the conversion from the values stored in C. Once it comes through the C interface, it will be represented as that 16-bit data, and then on the Swift side, I can take the 16-bit thing and represent it as a UUIDT, and pass using this constructor that we just saw here, convert that UUID value into an actual Swift UUID that I can use. So that is all about the schema. I didn't have time in the last stream to sort of explain that schema definition, but that's it. There's only a few enhancements that I need to do to it. One is making it, so by default, SQLite will make these a transaction, because I'll be executing multiple queries at the same time. So automatically this becomes a transaction, but you can also explicitly make it a transaction by having the begin transaction script as a line here, and you can have the definition of what should happen at the end. You can do that with commit. So the documentation that's described under transactions. So it's that window functions aggregate. These transactions. So this is just about yeah, I think it should be related to this. Yeah, so this is the transaction definition. So you start with begin, and within your list of queries that you are executing within this transaction, you can have save points that define at which point the rollback can unwrap everything that you did. So if you're executing a set of sensitive transactions that must all work together, this usually makes sense in like a banking environment where manipulating the customer's account must have some sort of atomicity. The transactions have to be consistent, otherwise you end up with what's the best way to describe it? Sort of like conflicts, where you've withdrawn and deposited the same or different amounts from a customer's account that don't really match the actual real life transactions. So it's good to have that that very specific transaction manipulation. The most obvious one is, for instance, in our schema definition, if anything goes wrong, roll back everything, so that if we have migration scripts executing together with the schema initialization script, if anything goes wrong with the migration script, one table is migrated, another one is sort of half updated, then you're better off unrolling the whole transaction instead of having it half migrated, which might give you problems later, because if you're again running the migration script, it might develop some conflicts. You're trying to alter a table that was half altered. You expect that the column is actually text, but the script already changed the column into a blob or a decimal value, and when you're running the migration script, it finds that the expectation for the current state of the schema and what you're trying to change it to do not really agree. So it's better off if you are running that migration and it doesn't succeed, it's better off for you to just unroll it. So for my case, I'll be having something simple. I'll just have a begin clause and then have commit at the end, so that if anything goes wrong in between the schema definition, when the schema definition queries are being executed, if anything goes wrong, then that whole migration cycle is basically rolled back. The database goes back into its initial version. So this is the structure. So you begin, defer, immediate, exclusive, and then you have your transactions, which are your SQL queries. And then you have the commit statement. So you can have this commit in multiple points in your list of queries, or in your batch of queries, in the set of queries that you're executing. So you might reach a point in the execution where you're comfortable doing a commit here, because the subsequent queries do not conflict with any of the queries above. If they're executed halfway, the initial queries will still be okay. Then you can do a commit. So that commit can be called multiple times. And of course, you have the rollback. And you can, like I mentioned, you can define a save point. Yeah, so end transaction is just similar to commit. That's why in our case, I'm calling it at the end. Yeah, so there's a lot of transaction manipulation functions that are available here that can allow you to have more fine-grained control over how your queries are executed, especially when you're executing multiple queries in one go, like in this case. So now that this is done, what I'm going to do is, to be correct. What I'm going to do is, this is between. So I presume that there's a lot of errors in the queries I wrote last time. Some of them I can I can pick out now, but probably I'll be able to, I might miss a lot of them. So the best way to know that this works is to have a test that executes this query on SQLite and see whether the schema definition succeeds. And also I can use the SQLite CLI utility functions to also check the schema myself and see whether it actually represents what I was hoping that it would. So what I'm going to do is write some tests, which I sort of already started writing last time. Yeah, so there's this schema initialization test. So in the next few minutes, I'll try and get the schema initialization test to work, which means I think it's pretty much written. The test itself is pretty much done. What's left is figuring out this init schema function, which is being called by the test. So once this schema init function is working, and I'll know that by the test passing, then I think this bit will be pretty much done. So that's what I'll be doing in the next few minutes, and then I'll come back to see what the next step might be. If we have the schema, the next thing will probably be defining a way to initialize the start point state for the simulation, and see how things go from there.
Welcome to VoiceOver. VoiceOver speaks description.
I think I have something here for the init schema component of this. I think this might get the job done. And the first thing I'm doing is I'm checking that the reference to the SQLite object, which in our case represents the database, is not a null pointer. Just checking it for nil. If it is a null pointer, I'm returning this error message, nil database error, which is a custom error message. It will come with the preset displayable error message for the user. Then the next step is using the schema, which is this string, to create a C string. Like I mentioned in the previous streams, C and Swift handle strings very differently. In C, the string is an array of characters that's null terminated, and all you need is the pointer to the first index of that array, and you iterate over the next indices to read the whole string. While in Swift, being a more modern language, a string is represented more or less like an object. In fact, I think just like in Java, Swift represents strings as objects, so it's less high level. Then so this converts the C string into the Swift string into a C string, and what we get here is what we call the base pointer, the pointer to the first string, and we can pass that to C, and C will be able to find the representation of that string in memory from its first index and be able to read the whole string. And we are passing that to this SQLite 3 execute function. So this is a generic function in the SQLite C API that supports executing an arbitrary set of queries. So it can execute a data definition query like what we are doing for initializing schemas. You can execute modification query. You can execute like an alter table query for modifying the schema. It can also execute a query where you're just modifying the data, like update queries. When you're doing select queries, this might not be ideal. You might probably need to have a prepared statement that passes in the values for the where clause. And when we're working with prepared statements, I believe this function doesn't accept a prepared statement as an argument, so we work with a different function. So this just accepts the SQLite object, the actual SQL query, or the string that represents the batch of queries that you want to execute. And you can have a callback. I'm not going to use that because I can obtain the status code, which is returned as an int, a cint. And if I'm looking for an error message, you can pass a pointer to a string so that C can update that string with the actual error message. But there's a SQLite error message function that's available for that, so you don't need to pass that in. So that's why I'm passing the other values as nil. So if this executes correctly, then we'll get a result code, which can be SQLite OK or some other result code. And that's why I have this check. So this checks that the result code is okay before proceeding. If it's not, then I'm attempting to extract the actual error message, because if the status code is not SQLite OK, it means something went wrong. And if I find the error message, then I'll append it to the schema initialization error as the wrapped in error message. If not, I'll have this general error message that includes the status code, so that the status code will act as a hint to debug whatever went wrong. Yeah, so that's pretty much it. If this is status code okay, then what I need to do here is just return a success state. So I can just say success. And since I'm returning void for success cases, I don't need to pass anything here. I'm expecting this to kind of get the job done, but if anything is wrong with the queries or the way this function is written, then I'll be able to figure that out from the test. So I'll just go ahead and execute the test and kind of see what happens. Test has failed. And I think now I kind of have to figure out why the test execution failed. I'm not seeing any of the defined error messages, which might mean perhaps there is a need to update the test. Just go to the schema init test, I think. So for a success rate, we'll get that. And the error we're getting is failed to init SQLite schema, expected success result. So we didn't get a success result. And when we don't have a success result, I think the thing I need to do is to print the error message within the test that we're able to debug it. And to do that, I think it should be a simple matter of introducing an extra case here, a case.failure. For this, if the failure happens, we should get an error message. Missing if. And now have an error message, then I can just go ahead and print it. The assertions, in this case, although in Swift, we're using a macro that's referred to as this require, but I wish they just use the word assertion because it's basically an assertion. So the assertions here just already check for whether we get a success state or a failure state. So what I'm doing is just printing the actual error message if it's a failure state. But the test itself would, the way it's written, it will always fail if we have an error state, whether or not we will print out the actual error message. So now with the error message, I can execute it again, and hopefully, if we even got to a point where SQLite is giving us an error message back, we should be able to see that. So it's not even getting to that point. Yeah, which might mean I might have to employ breakpoints. We want to see where the failure point is. And judging by this SQLite error, not an error, it could be, okay, no, that's during the execution of, a different test. So the execution of the test we are concerned with is from this point. Should init schema test. So this happens before. Execution failed. Oh, actually it starts here. So this is actually related to the test. So I suspect the failure is happening at the point where we are extracting the error message. And if we don't get an error message, I'm expecting that we should still be okay. Slightly be slight error, not an error. So let me just prefix this with the SQLite error message, so that I can tell whether that's coming from here or from a different source. I think that should be okay. Oh, need that one. Okay. So actually that is not the source. SQLite error message. I'm not seeing that. So where is this coming from? Let me just attach some breakpoints, and during execution, some of the breakpoints will be able to pick up where the failure is happening. And if I execute it from this the CLI, I don't think the breakpoints will work, or will they? No. So I think I have to execute it from the IDE. Okay, I see what I'm doing wrong. So, I'm doing two separate interactions with SQLite here. The first one is extracting a database object, and having this clause here doesn't help. Instead, I was supposed to have that at the point where I'm doing a schema initialization. So under schema initialization, we have the success state, and then you can check for, if you can check the result of the schema init. So this should be schema init result. Because what I'm trying to do is, before the assertion fails, I'm trying to see the actual error message that comes from SQLite, that you can use that to debug. Still not seeing that log. Is it? Are we getting a schema success? Yeah. So this is happening, but this is not being printed when I execute Swift test. Strangely, but it's printing. Okay. Perhaps I'm supposed to like use a logger before it's printed of the CLI. It means my logs won't be printed of the CLI unless I use a different API. Okay. That means I'll need to use the IDE to kind of visualize them for now. But I'll look into how these print statements can make it to the CLI execution of their test. I'm getting nothing. Oh, okay. So schema init error, the operation couldn't be completed. Okay, that's very vague. Error 1. The operation couldn't be completed. I wish SQLite gave me more than that. Yeah, this is a vague point to be like debugging from. So let me just check the init code again. So these breakpoints are useless, they won't be executed. Or maybe I've picked the wrong breakpoints. Couldn't be executed. All the error messages I'm using have a sort of prefix. So let me just see if schema init error. Okay. Operation couldn't be completed. let me try doing a dump of the the whole error object. Perhaps I can get a bit more information from that, because at this point it's very vague. It's not very clear what really went wrong. Let's even execute. Okay, the dump is not printed. Okay, this is, oh, okay, I'm actually printing the dump at the wrong point, so it should be here. Okay, so the dump has given me the correct thing. So nil database object, check connection. So for some reason at the schema initialization phase, the database object seems to be deinitialized. It's not active anymore. So it probably need to see what I'm getting wrong here. So this database object, but I'm already checking it for null. So that means the test is failing here. It's not even getting to the point where the database queries gets to be executed, because that's a nil database error. Nil database object check connection. Could be the test. Let me see the test. So I think the problem could be this assignment that I'm doing at Learn 19. Perhaps when I do the assignment into this object and we exit that scope, the object is initialized. I'm supposed to use the actual database object that we get from executing get database. So if I assign it to something else, it's no longer active. I think that could be what's causing the problem. But I didn't expect that would cause any problem. Hey, Agent Smith, Dev Singh, thanks for joining the stream. Okay, so this might mean that perhaps the way this object is, but it's something that we can check for. If this DB object was in fact null, this assertion would fail. So the fact that the test actually fails here and not here sort of tells me that this object is not, the pointer is not deinitialized per se, it's still active. Probably there's something else that I'm doing wrong. We'll just add an extra log here. Just to make sure that error doesn't have a different origin, and we just make sure that it's actually coming from init schema. Okay, db passed to init schema is nil, or is it? Yeah. Again, yeah, I've written the guard statement is incorrect. So what I'm doing is I'm checking that the database object has to be nil before we proceed to execute the other transactions, when in fact I'm supposed to check that the database object is not nil. Yeah, so guard statements usually work in the opposite of if-else statements. So if the statement is false, the internal scope will be executed. If it is false, then the flow of execution continues. So I tend to make that mistake. I think that's the mistake we're making. In fact, I'll just try and execute the test again, and test should init failed expected result. That okay. So yeah, so now it fails with a different error message. The problem we have is SQLite error message near exits syntax error. So there's a syntax error in the schema. So that's some progress. So now we can debug the actual schema, and maybe this is a good opportunity to get rid of any additional noise I might have added here. But this is a test. I think I can leave it to be noisy. The production code is still clean enough. So there's this near exits. Oh, okay, should be exists. Wow. I've kind of misspelled it so many times. So it's not exits. Supposed to be exists. Okay, error near something. So there's an extra closing bracket. So I think it's with this check constraints, check score between 0 and 1. I think the expression needs to be in its own brackets. And here we have check level in that. Then we close it. Check relationship in that, then we close it. Default date time, and check effect score between that and that, just to make sure. I think that should be okay. Okay, syntax error near between. So I'm using between multiple times here. Decimal. So let me try changing that to 0.0 and 1.1. So if that fails, I'll do the opposite. Okay, yeah, so the problem is still with that between flowers. We try using decimals. If that's not the case, then it might mean either they shouldn't be in brackets at all, or we cannot use the between expression for a check constraint. One of those. So let me first try using 1 and 0, which I don't think 1 and 0 would be the problem. The problem could be either putting them in brackets or the between clause is not allowed for, yeah, between clause is probably not allowed for the check constraint. So let me unwrap it to not have the brackets. And these are the only two places where I'm using between, so it must be one of them. So it's either 20 or 57. Let's see. Okay, an extra bracket somewhere. Check effect score between 1 and 0. Okay, this one is okay. Check score between 1 and 0, 0 and 1. Level int, check level in that and that. That should be okay. Relationship text not null, check relationship in that. And timestamp text not null. Okay. This one seems to be okay. Let me try unwrapping that check, which means we might you might not need to use like a check constraint for it. Try changing it to between 0 and 1. Okay. Okay. This can be changed to something else. You can do score is less than or equal to 0, or score is less than or equal to 1, or greater than or equal to 0, and so that's the check. I think that qualifies as an expression, so there shouldn't be a problem. Let me make sure of that. Okay. So let me try replacing the other one with the same constraint definition. They're sort of the same. This should be and, not or. So not null check. Let me just make sure that extra bracket error is not coming from the between clause, and what I can do is comment them out. I think that should be enough to comment them out. Okay, yeah. So SQLite error near display number. Display number. Display number decimal not null. Okay, syntax error in the display number. Okay, so my commenting out strategy is not working. So, oh wait. Okay, I was missing a comma down there. Let me just make sure that's okay. So now we have that extra bracket thing. So it seems the extra bracket problem is not related to the check constraint. I just need to figure out where it is. I think it's coming from this data call because this was pretty much an experiment. So let me get rid of default first. Okay, yeah, so that's what was causing the problem. So now let's see whether I'm able to use the check constraint with no incident. Okay, yeah, I can use the check constraint to do that. Could I use between? I think the problem could be using between 1 and 0. No problem with that. That's good. Which means I could also change this to use the check constraint, but instead of having this convoluted thing, I could just say score is between 1 and 0. Like that. Okay, so the test is passing, which means the schema initialization is probably going well. So I'll just go into the database and check the schema. Okay, and it looks like we have the schema. So, oh wait, this is unfortunate. Okay, I'm not doing versioning for the schema. So the first time I executed it and it passed. When I executed the second time, I think SQLite is matching the schema I'm passing in and the old one, and it's noticing that they're all the same. So it's not trying to update it. So the next thing I need to do here is do versioning, which I know I should do, but I really don't know how to. So let me just check the docs for that. I think it should be under something like migrations. Commit history. Version numbers, right? Version numbers now. Changes. Oh. Schema version. Version. Schema. schema version. Okay, SQLite schema. Pragma schema version. I think this is what I need. But I need it for setting the schema version, not querying the database for metadata, which I think that's the general use of Pragma. I don't know if I can use it to set the schema version. The Pragma queries that the value of the legacy alter table flag, when this flag is on. Okay, so even if I use the versioning, I'd need to, instead of executing create table if not exists, need to execute alter table. But since this is the first time I'm setting up the schema, it doesn't make sense to do that. Although I still need to know how the version is set, I'm not too concerned about having alter table queries in the schema at this point, until there's some data in the tables. Then it would make sense to add those queries. So what I'm going to figure out how to include the version, but then I'm going to delete the existing schema and re-execute it until the constraints are defined how I would want them to be. It's not very clear where I need to go to on the docs to find that definition, so I'll try and Google it this time. So what I'm looking for is SQLite schema version. I'm still referring to Pragma. It's a version. You can create a dedicated tracking table. I didn't want to do that unless I have to. Every SQLite database contains a single schema table that stores the schema for that schema for database is described a description of all of the other tables, indexes, triggers, and views that are contained within the database. The schema table looks like that. So it's already present in the database without me having to create it manually. So I guess what I need to do is update that table with the schema version. And then when I do migrations, I need to query that table, see what the current version is, match it with the version of the schema that I'm trying to use, and see whether I need to execute any table alteration queries. Mukesh, hey, thanks for joining the stream. Yeah, I can see your comment. I was just reading the docs here. And Diku, welcome to the stream. So I don't have a dedicated config for SQLite. I'm taking a more of a lightweight approach. Convention over configuration. So I don't want to specifically configure it. The only configurations thing that I think I might have that I have set up is the concurrency approach. So in my package.swift for importing the SQLite lib, I've defined use of threadsafe1, which allows the application, the queries to be able to like execute in multiple threads. Although I'm sure the individual database says will, whenever you want to execute a query against the database, you will, with thread safe1, you acquire a lock to that database table, you execute the queries, and then once you're done, you release the log. So if there's another thread that's trying to update that database table, they'll have to wait for you to release the log so that you don't have concurrent writes. Or error callbacks. Yeah, I'm not using error callbacks, Ndiku, and instead of passing a pointer that will be updated by SQLite, just calling SQLite error message to get the actual error message as a string, and printing that or returning it as the error message. And then once the scope within which I extracted that string is closed, for example, if I've already converted it into a Swift string, I can release the pointer to that error message. But for instance, if you look at the schema init, so I'm executing the query for initializing the schema at 69, and then depending on whether the status code is SQLite OK, which is status code 0. If it's not 0, then I'm calling SQLite 3 error message to extract the actual error message. And in some cases, that error message might not be available for whatever reason. So if I'm doing an additional check to make sure that the pointer that C passes back to Swift is not a null pointer, it's actually pointing to something. And if it does, then I'm converting that into a Swift string. So in fact, that's happening here. So if the pointer that comes from SQLite is null, then we'll end up with a null string, and this guard statement will be able to catch that. If not, we have an actual error message, and I can return that error message as part of this SQLite 3 error. And you can notice the function is using a result object. So that result object allows us to wrap an error message if a failure happens, and if a success state happens, of course we pass nothing, because success state is expects a void. Have you thought of considering null pointer? Yeah, that's why I'm doing a lot of checks for null pointers. So I don't need to check that this error message is not nil, but I'm checking for that. And also the database, because I'm using an opaque pointer, the actual SQLite object, I'm checking that it's not nil before I try to do any execution. So I'm doing a lot of null checks because of the fact that we are using pointers. And that's the only way you can communicate with C. It has to be through pointers. Yeah. So plenty of null checks in any case where we are passing a pointer, either from C to Swift, or if you are passing like a string. Okay, I'm glad you got it. But anyway, that's like what we are doing. So the Swift representation of these C pointers, or rather the Swift mapping of those pointers, is still new to me, but I'm getting hang of it. The available pointers is not just opaque pointer. There is unsafe mutable pointer when you want Swift to be able to mutate, to change the value if you want C to change the value that your pointer is pointing to from Swift, you can pass unsafe mutable pointer, but then there's a bit of restrictions to guarantee safety. For instance, sort of the way Swift is guaranteeing some safety, if I want to pass a string like this schema, which is a string, if I want to pass that to C, I'll have to call this with C string, which opens this scope. So it creates a closure. So the pointer to this string is only valid within this closure. So once that closure completes, or once you exit it, this schema pointer is automatically deinitialized. So Swift automatically clears it from memory, so that you don't end up with dangling pointers or unsafe operations. So that's one way you're getting safety. And I'm also doing null checks whenever I need to. Okay, I'm glad you got it. Mukesh is saying, BTech first year, can you give me the roadmap and explain what you're doing? So I'm in, where do I start? Yeah, so generally I'm building sort of like I'm building a simulation. So it's the idea is to build like a governance simulation where a user can pass in inputs, and you can have, so the inputs are passed in as policy statements, not really policy statements, but if you imagine the way government works, they set policies and then those policies affect how things happen in the real world. So the way the simulation works is the user will be able to pass in policies like changing the number of available hospitals or managing the population. It can be a number of things. And when that gets into the simulation, we apply some sort of probability function that determines what the effect of that policy change will be to the jurisdiction that we are simulating, and then have those values determine sort of like the matrix, which is like variables that determine the state of the simulation with a bit of randomness, and with that sort of try and simulate the way in real life a policy thing that's done by government surely affects various parts of society. Yeah, so it's still a rough idea at this point. My main goal is a technical exploration of building simulations, not necessarily the idea of what the simulation will do. I want to explore things like C and Swift interoperability. I want to explore things like working with some C libraries in Swift, and starting, of course, with SQLite. I'm hoping to also do that with SDL, the graphics library, and see how that interoperability happens, as that perhaps that knowledge can kind of help me build more lightweight applications where the persistence layer, or if I'm doing graphics, the graphics layer is communicating directly with some C API, which means it will be slightly faster and more efficient, but also enjoy the safety that comes with writing Swift code. But the project itself is a simulation project. So it's a simulation that should kind of show us what happens when like a policy thing comes into the simulation. We apply some variables to that policy value that has been passed in, and simulate how those policies combined with other variables can affect other parts of governance, security, healthcare, education, and so on. Governance is very boring, so unfortunately I picked a really boring topic for the actual simulation, but the technical bit is rather interesting. So stuff like doing the game loop, writing some models that some isolated models. So for example, you can imagine modeling a hospital. How does number of beds affect whether a patient will get treated or not? Modeling something like public registry of the citizens. How does that affect productivity? Modeling taxation. If the tax rate is at this level, how does that affect the productivity of the population, and so on. So there could be some interesting ideas that can emerge from kind of writing this. But the main goal is technical exploration, which, it's mainly what I'm doing. Am I using post or get as my method? So this is not server-side, so it's purely it's not a server-side thing. So there's no REST endpoint. There's no there's no HTTP. So this is just something. You can imagine it as just a tiny program that can run on your machine. I could move it later into something server side where you have endpoints and you have those server side concepts. But at this time, imagine it as just a simple program. So it's not back-end development. Yeah, I've done plenty of that. In fact, that's why I decided to do something different with this. I've done, I think, in some of the previous streams, I've done some streams where I was live coding back-end development with Spring Boot, with Vapor. I think it's called Vapor, the back-end framework for Swift. Swift Vapor, I think it's Vapor. Yeah, this framework. So I've done some live streams in the past working with Vapor, and yeah, that was fun. But I want to do something different. So for this particular series of streams, it will just be kind of individual programs, not a whole backend infrastructure. What am I doing at night? Mostly sleeping. Okay, so I think I need to figure out how to update. I don't know if I could just write a query to set the database version on SQLite, or there's a specific way I'm supposed to do it, because I know the SQLite schema table should be present. So it's not present under my schema definition. I think the documentation mentions that so every SQLite database contains a single schema table that stores the schema for that database. So the question is this schema table preset, or do I need to create it? So it contains one row for each table. And I think by calling .schema, I think I'm sort of querying that table. So when I do .schema, I'm querying that schema table. Select from schema. No such table schema. Okay, so then that would mean it's preset, but I won't be able to access it traditionally. So just having a query in my schema to check the schema version with the simple select statement will not work. At least it seems like it would work. How do I interact with it? How do I interact with that default schema table? Okay, so SQLite doesn't have built-in schema versioning, but allows you to create a custom table to track changes. Okay. Okay, so it looks like we have to, I sort of have to create it. It doesn't, the SQLite doesn't automatically create the table, so sort of have to do it ourselves. No worries. Then just go back to the docs for schema table. I think the documentation is only talking about following the convention, that it should be this query that creates it. So you could just add that to our schema definition. And I could still have it here. Schema table. Then we can do an insert. SQLite schema. So for the type, what does type represent? So type, the SQLite schema.type column will be one of the following: table, index, view, trigger. So this is tables. Then we have the name. The SQLite schema name column will hold the name of the object. Constraint on tables causes SQLite to create internal indexes with the name of the form SQLite auto index table in, where table is replaced by the name of the table that contains the constraint. Okay, I was looking for something more global. So just have a database, a version for the whole database, and whenever we do a migration, I just check for that version number and determine whether I need to execute the alter table queries and which queries I need to execute. Page number of the root B-tree, page 40. This is getting a bit complicated. The schema SQL column stores SQL text that describes the object. Okay, this is becoming unnecessarily complex. So since this is not preset, I think I can just change it to what works for me. And what works for me is I just need the database version. DB version. And that should be it. So this is V1, maybe a timestamp. Okay, what will be that? If I use a timestamp, okay, that would make sense. So just the version is okay. So let me see what this other guy used. So the version and applied on. Yeah, but that depends on when. Oh, okay. By using the default timestamp as current timestamp, okay, it will tell you when that migration happens. Okay, that's in that sense, kind of makes more sense. Applied on, and this is a timestamp. Default current timestamp. Does SQLite contain a datetime? type. I don't think that type exists. Yeah. So SQLite has no datetime data type. Instead, dates and times can be stored in any of three ways: as text, integers, or real. So I don't know what this guy was trying to do here. Applied on date. Yeah, this would be invalid. This needs to be text, not datetime. So let me confirm. So I think default, I'll probably need to call datetime to set the default. This current timestamp thing doesn't seem to exist. Current timestamp. Yeah. So wait. Platform config. Current timestamp keywords will use the thread safe GMT-R interface rather than GM time. Okay, but you can call date time to obtain the current time. So you can find that under datetime functions. So yeah, I can call datetime to datetime returns the date and time formatted as that. Yeah. If the subsec modifier is used. So this should give us the current date and time by default. And I guess that means I could decide to not pass a value or pass null, and the default would be applied. Let's experiment with that and see what happens. Swift test. Not exists. Okay, that seems to have gone well. So SQLite, Gaussian, schema. Okay. Where's that table? What happened to the first table, schema table? It be the comments. Only see metrics. Okay. Schema, no schema. Okay. Oh, there's an error. SQLite error message, object name reserved for internal use, SQLite schema. But if it's reserved for internal use, why is the table not present by default? This is strange. Does it mean that the table already exists? SQLite schema. Select from SQLite schema. Okay. Seems the table exists. So if it does, let me try not creating it then and see what happens. So we have the schema and sim events. So the table is present and it has a bunch of things. Related metrics. So it creates a separate reference, it creates a separate schema tracking for every table. I think there is a situation here, which means it's not very straightforward. I was hoping for something I could just query for the current database version and determine whether I need to run migration scripts. Okay, so I'll not worry about this for now. When I get to a point where I need to do migrations, I'll worry about it. So for now, we have the schema initialization, but I need to also check that this only works because it was commented out. And to do that, I'll just get rid of the current database. Just execute. So there should be no schema right now. Schema, that gives us nothing. And if I run Swift test, we should, unless something goes wrong, we should. Okay, in fact, something goes wrong, and I think it's related to this default datetime call. Okay, let me try using that trick I saw on that article. So what if we use current time? Okay, current time seems to work. And can go to SQLite 3, Gaussian, and check the schema. Okay, so we have the schema with the constraints that we need to have. So I guess we can say schema initialization is successful, and we don't need this. Wonderful. So now that schema initialization is done, the next step is I could start working on the initial data for the simulation, but it would be best to start working on the actual simulation functions, since with the schema initialized and the test necessary for checking that schema initialization having been concluded, the next reasonable point to go to would be to now just start writing some of the simulation functions, because persistence is sort of taken care of. Let me see if I need to change anything before I commit this. Looks good. I don't think I need to change anything there. Schema init error. Okay, so that's the test, and the actual initialization logic lives here. It looks decent. So this is for issue 1. I don't even need to check. Okay. So the schema initialization step is done, and with that, I think I can move on to building the rest of the sim in the next stream. So this is already almost 2 hours in, so I think 2 hours is more than enough time. So in the next stream, I'll start working on a different issue, which should be related to just see the plan that. Okay, there's something that didn't go well. Invalid command code. Okay, so the coverage report sort of failed to print. I'll check that later. But looking at this issue 1, define all metrics at their starting ranges. Define metric relationships. I think we've done that with the schema. Target values for STG alignment, so this will be separate. So I'll just close this to open up opportunity to move to mapping how metrics influence each other. I think this is closed by the schema, but the actual business logic for how that mapping works hasn't been written yet. So advance time and apply pending effects, apply immediate delay metrics. Okay, so I think I'll need to have an intermediate issue here for catch-up simulated time when game reloads, for writing the game loop, because currently it's just the persistence layer. There's literally nothing apart from persistence. So before I move to generate prompts and the rest, I'll need to write some core logic for the actual simulation. So yeah, I'll figure out an intermediary issue to work on before I move to this, because these seem to be issues related to building beyond the point where we kind of have the core of the simulation working. And then I can work on prompts to the user. I can work on catching up on simulator time if somebody switches the simulation off. If they switch it on later, I should be able to find the time that has elapsed since then, and then kind of have the simulation catch up instead of resuming as if no time has passed between when it was switched off and when it was switched back on. Yeah, this drift while idle, random events each turn. This is related to the user interaction. So that's, yeah, I need to build the core of this thing first before all of that. So I'll figure out some intermediary issue for it. Okay. So it looks good. I'll end the stream there. If you joined or watched this later, thank you for stopping by, and see you on the next stream. Otherwise, this has been fun. Looking forward to building more of this project. Bye bye.